And we're all set. Okay. Excuse me. We're going to start with chapter 4 and start part 1A, which is the part about correlation. This is section 4.1. And when we're talking about correlation, we're looking at describing the relationship between two variables. In this course, we're just going to look at two quantitative variables, and we're only going to look at a linear relationship. So we often want to study the relationship between two variables, and when each entry in a data set corresponds to one entry in a second data set, then the sets are called paired data sets. And we're going to start by considering data from the 2016 Major League Baseball that shows the salaries of the players and the average attendance at home games. So for each of the teams, we have the salary in millions of dollars and the average attendance at each home game. And the question is, if we spend more money, do we get more attendance? Is that really a correlation that goes together? So when we're talking about plotting data points, what we're looking at is we have 2 points, 2 columns of data that go together. So we have the X and the Y, and the X in this case is going to be the salary, and the Y was attendance. And each of these data points correspond. We're doing X and Y from a particular team, like the Red Sox. And then we'll do X and Y from another particular team. So those are called sorry. So when we plot those points, we're going to plot it on a graph where one axis is the x-axis and one is the y. The x is the horizontal, and the y is the vertical. So they call those an ordered pair, where x always goes before y. So here's the one for Major League Baseball. For each of those salaries and average attendance per home game, we have one dot, and the X is the salary, and the Y is the average attendance per home game. The scatter plot or scatter diagram is the graph that shows the relationship between these two quantitative variables that are measured on the same individual, in this case, individual meaning team. So each individual or team is represented by one point in the scatter plot. Some important vocabulary is the explanatory or the independent variable is on the X or horizontal axis. So this is the explanatory or the independent variable. This is the variable we think may explain or predict the other. The Y is the response, and it's called dependent. The response meaning it's responding to the X, and dependent meaning the X is what is independent and predicts the Y variable. So it explains and makes what's happening with the Y variable. So the horizontal is the X and the vertical is the Y. A correlation is a relationship between the two variables, and you can usually see that relationship. We have 2 kinds of linear correlations, one that goes downhill and one that goes uphill. The negative correlation is the one that goes downhill from left to right. And as the X increases, so as these numbers on the X number line increase, The Y values are going down. So they start high and go down as the X increases. And that's called a negative linear correlation. Negative because they're the opposite. So as one is going up, the other's going down. The positive linear correlation, as X increases, Y also increases. So that is called a positive linear correlation. And it's called linear because it looks like a line. This graph here on the lower left has no correlation because you can't really see a pattern in the data. This graph here on the lower right has a correlation. You can see a very strong curve, but it's not linear because it's not a line. So it may have a correlation, but we're going to only focus on line or linear correlations in this book. But there are, if you go on in statistics, you can look for nonlinear correlations, which also matter. The correlation coefficient is a measure of the strength and the direction of a linear relationship between two variables. The symbol R is what we use for the correlation coefficient for the sample. And we're going to be working with samples. The population also has a correlation coefficient. It's a Greek letter rho, which is a capital R, and it's represented by this symbol. We're not going to really be using that, but it does have, just like a sample has R, the population has capital R, which is called rho. Our correlation coefficient is going to range anywhere from -1 to 1. A perfect positive correlation, which doesn't really happen with real data, but to give you a picture of the best it could possibly be, is a perfect line going uphill. And that would be R is equal to 1. The perfect negative would be a perfect line going downhill, and it would be R equals -1. These numbers don't have to do with the slant of the line, so it's not about the slant or the slope. It's just about how aligned the numbers are in a perfect line and whether they go uphill where it's positive or downhill where it's negative. Now, most data is going to be more like the data in the middle column or the right column. This is a strong positive correlation. R is 0.81, so fairly close to 1. And you can see that the data lines up in a line. Strong negative correlation, this one's a little stronger. R equals -0.92, so it's going downhill because it's negative. And it's fairly close to -1, so we have a fairly strong alignment. A weaker correlation would be 0.45. You can still see it going up the hill, but it's not very strong like the one in the middle. And here we have a weak downhill, which is also a big mess. This is actually probably closer to no correlation because it's hard to see where the line would be here. Now, we're not going to calculate that correlation on our own. We're going to be using StatCrunch.